lecture today. I'm going to talk about multi-threaded programming in C#. There's a couple ways to go about doing this. The lecture comes from Chapter 16 in my book, C# for Artists, second edition. And Chapter 16, now this image that you see on the first page of the chapter comes from when I was stationed on board USS Norfolk SSN 714, a fast attack submarine back in the 80s. And it just so happens that in this multi-threading chapter, the image I chose was the ship's dock, hospital corpsman stitching up a guy who had cut himself. If I'm not mistaken, he was loading the trash disposal unit and cut himself on the metal galvanized container that is used in the trash compactor to hold the trash. So thought it was an apropos photograph. Anyway, the learning objectives are define the term process and thread, explain the difference between a process and a thread, explain how time slicing works, state the definition of the term multi-threading, list and describe the steps and components required to create a multi-threaded program, create and start threads in a program with a thread class, pass arguments to manage threads using parameterized thread start delegates, explain the difference between foreground and background threads, use the background worker class to create multi-threaded programs, use delegates to make asynchronous method calls, pass arguments to and obtain results from asynchronous method calls, create background threads using the thread pool class, and demonstrate your ability to create multi-threaded programs. Now, you know, to cover this whole chapter in one video would make it a pretty long video, so I'll probably break it up into a few different videos. I'll start with an overall introduction of thread programming in this video, and then in subsequent thread programming videos, I'll talk about the thread class and the background worker, class, and then I'll talk about asynchronous method calls, and then I'll talk about thread pools, probably a separate video for each one of those. Okay, so let's get going. All right, first off, threading is a valuable tool belt to add to your programmer's skill set. Okay. I should say a tool, keep with the same metaphor, a valuable tool to add to your programming tool belt. First off, a lot of times every program consists of at least one thread. That's the main thread for the main method. But sometimes, your program is more efficient if it does other things at the same time as it's doing something else, right? Okay, if you don't know how to do multi-threaded program, that kind of puts you at a loss, and it's a little complicated, but on the other hand, the .NET framework makes it very easy to do multi-threaded programming. And it comes quite handy, especially when you're doing multi-threaded client-server programming. So really an understanding of multi-threading leads to the ability to program other very useful types of applications. Okay. Now you can overuse multi-threading by trying to do too much multi-threading. So just a right balance of multi-threading might make your program responsive, whereas too much might drag it down. Okay, so there is a balance there. So you don't want to overuse it. On the other hand, using it in the right measure can really make your program sing. Okay. Now, when I wrote this book, it was October 2014. No, when I edited the first edition, it was October 2014. Now it's December 2015. I'm doing this video. And I always, even now, when wintertime approaching, I still get the hankering to go on vacation, right? Anytime the weather turns chilly in Virginia, I get that hankering to go on a vacation. So let's talk about threading first in the context of two vacations. One vacation is going to be single-threaded, and the other vacation is going to be multi-threaded. And we'll see how we feel after the end of each one. So imagine for a moment you're on a sun-drenched beach and squeaky white sand down in the tropics. And since you're on vacation, your mission is to relax. And as you start to drift off for a snooze, you begin to get thirsty. You know, you're the only one on the beach, maybe you and your wife, and the bar is a mile away. So, hey, there's no waiters. So you're going to get up and you're going to walk to the beach, or to the bar to get a drink. And you do. But since you're going that far to the bar, you might as well make it two, right? You walk back to your lounge chair. Now you start to relax again. You start sipping your drink. And now you got a drink. Now you're getting a little hungry. The grill is a mile in the other direction. So you got to get up and walk to the grill. All you really want to do is relax and enjoy the beach. But you end up doing is a little relaxing, right? And you do some drink fetching and some food fetching. Eventually, you'll get back to relaxing because, after all, you're on single-threaded vacation. But now let's have multi-threaded vacation. Imagine you're on the same beautiful beach. This time, when you get thirsty, you can just snap your fingers and ask the wait staff to bring you a drink. And they immediately go off and go get your drink. And you immediately return to relaxing. And then when you get hungry, you summon the waitstaff, and off they go to fetch you a little something from the grill. And then you immediately return to relaxing. So multi-threaded vacation sounds so much better, right? I like multi-threaded vacations. And if you've ever returned from a vacation and felt like you needed a vacation, you probably didn't have a multi-threaded vacation because you were never allowed to relax. So let's talk briefly about the relationship between a process and its threads. In the tale of two vacations that I just discussed above, you could think of yourself as being a process. You got the relax process, right? On a computer, the operating system loads and starts services and applications. And each service or application runs as a separate process on the machine. Now, just a note, a service is a special type of Windows application that runs solely in the background with limited or no interaction. So, if you ever pull up the services window, and if you're if you're not an admin, you probably have never done that. But, look for it. It's in the admin tools section. So any of your control panel. So we come down here, figure 16-1 shows a list of applications running on my machine at the time I wrote this book. So the applications that were running was I had a folder open with documents, right? I had Introduction to Windows Service Applications running, and had a Windows Internet Explorer app going. And I was on a Pulp Free Press home website. Okay, that was the applications. Now, if I go to the services, right, or processes, I should say, I click on this other tab up here called Processes, and you'll see that I have a whole lot more processes running than I have applications running. Okay, and this is just a partial list because you'd have to scroll down to see them. Okay, if I took this from the current machine that I'm working on right now, right? Let me move this thing over a little bit, center it up. Okay, and I go down to, oops, sorry, that was too far down. I go to, I think I got it right up here. What you want to do is you want to right click to get to that window on your desktop. Let me see here. Oh, excuse me. That's not what you want to do. You want to go to My Computer. Yeah, Okay, to get to that screen, I need to open up the Task Manager. But since I'm running a VM here on a Mac, I need to go up to the keyboard piece, which you can't hardly see, and send a Control-Alt-Delete to get the window. And then I got to start Task Manager. There we go. All right. So applications, I'm not running any app. Let me start up an app. So I'm going to start up Notepad++. All right, and that's code from the last example that I did. So let me minimize that. And now we see that Notepad++ is running. Okay. Processes. All right, let me expand this window. Okay. Even though I only got one app running, I got a lot of processes. All right, and processes are, depends on the services that you've got running. You got operating system A lot of these services are dependent upon by the operating system, okay, for the proper functioning of your machine. All right, so let's go back to processes. We come down here, we see, let's expand the descriptions. So I've got Adobe Acrobat Update, Parallels, Coherence. So if I move this VM out of the way, so that's my Mac right there in the background. This is my Windows VM that I'm running for this video. And that's running in Parallels, okay? I got console window host. There's a whole bunch of them, right? Notepad++, right? It's got a process. Now services. Services are we find service in our services. So, the services shortcut looks like this. Well, the services app icon, right? So if you double click that and open it up, this presents you with the window on how to, start and stop services. Okay. And so we can expand this up, and these services, like I just pointed out, are most of them are critical, right, for the proper operation of your machine. And if an important service were to stop running or failed to start, then your computer wouldn't act normal, right? It wouldn't function as you expect. Okay, so anyway, I just wanted to show, so I got my services, right? My services is running. I just minimized it. Now I got my services app running, and Notepad++. Those are the two apps that are running. But even though I only have two apps running, I got tons of processes, right? That things like I've got SQL Server because I've got that installed, right? Anything that starts up automatically as part of the system startup, that'd be a process. And then any particular services, right? Some of them are running, some of them are stopped, right? It just lists all the ones that are on the machine. Okay, so I can get rid of Task Manager for this point, and let me go back to the book. All right, so there we go. All right, so continuing on. A process consists of one or more threads, okay? You got your app, and usually your app runs in a process dedicated to that application. The process that is running as part of your application can have one or more thread. If it's single threaded, it's only got one thread. That's the main thread. Main is your entry point for your program. Okay? And if it's got more than one thread, we can talk about threads of execution or simply threads, right? A process always consists, like I said, of at least one thread. A single-threaded process contains only one thread of execution. A multi-threaded process contains more than one thread. So in a computer, if you look at figure 16.3, I can expand this a little bit, make it a little bit bigger. Okay, here I've got a single processor computer, right? You don't see those much nowadays, maybe little embedded machines. But for the most part, most modern computers have multiple processors, right? But you can still get multi-threaded behavior on a single processor because of time slicing. Let's go through this. Okay, so here's main memory up at the top. Okay, and I've got two processes, process A and process B, and those are going to be associated with two different applications. And then I've got the operating system has a thread scheduler. So, your operating system has to be capable of providing multi-threaded services, right? And the way that's done is usually with a thread scheduler, okay? And then your language has to have some way of creating the multiple threads, okay? So if we look up here at process A, it's got a main thread and then two extra threads running. And if we look at process B, it's got its main thread and then three additional threads running. So you got 3 threads in process A and 4 threads in process B. Now, how do all those threads run on a single processor, right, in a computer with a single processor. And, there's different algorithms, right? But generally it's a time slicing scheme where you have a thread waiting queue or a waiting thread queue. And when a thread starts up, it usually goes into the queue before it gets a little time on the processor. In order to swap out the processor, you have to take the context of the processor, a snapshot of the register states, okay, the program counter, where it's going to go next, okay, and then that has to be like almost taking a picture, and then preserve that off in the thread context, and it's this thread context that goes into the waiting queue, and then threads are swapped in and out. And computers nowadays run so fast that you can swap these thread states, right, or the thread context in and out of the processor so fast that you think things are happening simultaneously when actually they're happening in sequence, right? But in other words, you get the illusion that two apps are running, or more apps are running simultaneously on the machine because of this time slicing, swapping out of the thread context. Now, if we go on and we look at another instance, all right, so there's a term in there I want to go over called preemption, okay? When it comes time for a thread to get a little piece of the processor, it'll run for a certain amount of time, however the thread context, however the operating system thread scheduler schedules that, right? But then as soon as another thread comes along and it says, hey, I need my turn, then that's called preemptive. So in other words, a thread might have a higher priority than another thread. Some schedulers treat all threads equally, so everybody gets fair treatment. Okay, you can set thread priorities, right? But the problem with that is that if you have everybody set at a high priority, then you're starving some other thread for processor time. All right, so these thread contexts are being swapped in and swapped out. So when a thread that's being currently serviced is then taken off and put into the thread queue, and another thread, okay, that's called preempted. So that thread that was processing is preempted and then replaced by another thread, okay? Now, in a multiprocessor computer, you do actually get true multiprocessing and parallel execution, right? And modern processors usually have more than one core, right? You got the processor, that's the core. Well, you got packaging that contains more than one core, right? So for example, you can buy a 4-core, a 2-core, a 4-core, a 6-core processor, right? You put 2 4-cores in a machine, you got 8 cores. And then they go on. Intel's got hyperthreading. So you've got 2 virtual application. The term I'm looking for is a logical execution paths units, right? So even a 1-core actually looks like 2 cores, right? Because you got this hyperthreading capability. So a 2-core process has 4 logical cores, right? It might have 2 physical cores, but it looks like it's got 4 logical cores. Okay. Now, you get the same type of context swapping, but with this processor, multiprocessor, right? Your app has to be, you're not necessarily running, swapping out these threads willy-nilly on each of these processors. There's probably a processor affinity associated with an app, right? So if it starts running on this processor, all the threads will be on that processor. But multiple apps might be using multiple different processor. That depends on how the app is written. I tell you right now, a lot of apps are not written to take full advantage of multi-core processors, right? So you might have tons of cores laying around, but that doesn't mean they're all being used efficiently. So for an example, let me see if I can pull up. Here I got the Macintosh activity monitor, okay? And I got my CPU here. And it just shows a bunch of processes running. So I got threads 1,542, 1,550 because I just opened this app. Memory. Get the nice, pretty looking picture of the thread of the processors. But here I got my CPU load. It's hard to tell how many CPUs I'm using. I have to look for a better way to show this. Anyway, that was a nice little aside. Okay. So vacation got bad. There is possibility, even on a multi-threaded vacation, for you to return home. Okay, vacation gone bad. There's a possibility, even on a multi-threaded vacation, for you to return home tense and frustrated. This can occur if the drink and food fetching threads misbehave. Now, how might this happen? So assume for a moment that you're not the only process on the beach. Laying next to you is a nasty little someone named Create, Hate, and Discontent. And he told his food and drink fetching threads that they were special and gave them an order to cut in front of the line whenever possible. So your threads get booted from the bar and grill counters more frequently because of the higher priority Create, Hate, and Discontent threads. You suffer because your drink fetcher and your food fetcher threads no longer take longer to fetch food and drink, right? That's because they're getting preempted from the processor more frequently. So anyway, as a review, a process consists of one or more threads of execution, and we'll just refer to these as threads. A process always consists of at least one thread, and that's the main thread, represented by the main method. And the main method starts running when the process begins execution, or when you double-click the app, it's loaded into memory, and then processing jumps to the main. A single-threaded process contains only one thread, so a single-threaded process contains one thread of execution. A multi-threaded process contains more than one thread. A thread is the smallest unit of code to which the operating system assigns processing time. Okay? A thread executes within the context of its containing or owning process and application domain. And waiting threads sit in a thread queue until they are loaded into the processor. Each thread has a data structure known as a thread context. The thread context is a snapshot of the state of the processor and other execution details that must be preserved so that the thread can pick up where it left off when it's next loaded into the processor. And then a single processor system, the operating system allocates processor time with a time slicing scheme. And each thread gets a little bit of time to execute before being preempted by the next waiting thread. Okay. In a multiprocessor system, two threads can actually execute concurrently, but the operating system still uses time slicing to manage their execution and keep the whole thing running smoothly. So that was an introduction to threads. Okay. In the next video, we'll talk about creating managed threads with the thread class. And look forward to seeing you there.